Good morning. So today what we're going to do is we're going to do an example of how to establish the identity. The first thing that you need to know about establishing an identity is that when these are the directions, what you need to do is draw two columns, one for your work and one for the reason that you were able to do each step. What this direction establish the identity means is to work with one side of this equation, usually the most complicated side, and make it look like the other side of the equation. Okay? Every one of these problems is going to be different, so you're just going to have to try some things and see what happens using all the properties from the last two videos. So for this one of the first things that I notice here is that I've got a sine, a cosecant, a cosine squared, and a sine squared. So what I'm going to do is change this cosecant into its reciprocal, because the reciprocal of cosecant is the sine. So I'm going to say the sine of theta times 1 over the sine of theta minus the cosine squared of theta equals the sine squared of theta. I have decided to use the left side of the equation to work with, and the right side of the equation is going to be the same all the way down. So what I used here to change the cosecant to the sine was the reciprocal property. So I'm going to write that over here. Now the next thing that I'm going to do is I'm going to go ahead and multiply these two together. So sine times its reciprocal is 1. Okay, so sine times its reciprocal, excuse me, is 1. This is the inverse property that we learned way back in probably Math 1. So this, anytime you have a number times its reciprocal, it's always going to give you the identity. So when you multiply two multiplicative inverses, you always get 1. That's the inverse property. Then hopefully you will recognize this. 1 minus the cosine squared is the sine squared. And that is by the Pythagorean identity. And now I have an identity. I've changed this left side into sine squared, and now it equals the right side, which is sine squared, and so I'm done.